I'm going to start by being informal and taking my jacket off because this subject makes me very excited. It's fabulous to be here. One of the benefits of giving these lectures is that they force me to think in new ways, and articulating one's knowledge and thoughts to an audience results in better thoughts. And so I thank you very much for giving me the chance to learn by talking. And I didn't actually think I was going to be at this point when I started with the first lecture a month ago. The second thing to say is the advantage of having 3 lectures is that many friends can't make it to all 3 lectures, but many friends can make it to 1. So it's wonderful to see so many friends and former students here. So let's go. I've got a lot of pictures to show you, and what I think is a potentially worthwhile conclusion that only occurred to me 10 minutes ago. I've actually added a slide at the end in the last 10 minutes because of the benefit of this energy in the room. Okay, let's start. Look up is, of course, a play on words, right? Because we look up at the Arctic, we look north, and we look up at space. And the Arctic, well, Canada is an Arctic nation. 40% of this country is Arctic. We have the longest coastline of any country in the world because of our Arctic coastline, because of our 19,000 Arctic islands in the high Arctic archipelago. That are ours, including the one that's disputed by Denmark. This map gives you a better sense. This is a map looking down at the North Pole. Any perspective on Earth is valid. It's a sphere in space. And this gives you a sense of the Arctic and Canada's place in the Arctic. Notice how big Canada is. I mean, Churchill just manages to get on this map. Fort McMurray just manages. Prince George just manages, right? Forget about Vancouver, Toronto, Montreal, right? They're on the periphery. Canada is the second largest country on Earth. And again, 40% of it is Arctic. And the Arctic is part of our national consciousness, right? Whether it was the European explorers, the Franklin expedition, which famously became lost and prompted literally dozens of rescue attempts. This image of the brave explorer going out into the savage land and sometimes perishing, often perishing, was part of a heroic enterprise that forged a sense of Canada as an Arctic nation. It wasn't confined to the Anglo part of Canada. This gentleman, Joseph Bernier, is as big a name in Quebec as John Franklin is in English Canada. A great Arctic explorer who mapped much of the high Arctic archipelago with his vessel, the Arctic, which you see behind. So for this reason, the Arctic is actually something which unites the 2 solitudes in this country. It's one of the few topics I found that actually speaks with equal resonance to both English Canadians and French Canadians. Well, because you're an English Canadian. So I'm telling you about him right now. The Arctic is in our national anthem, or at least in the English version, the True North, Strong and Free. It's not actually in the French version. I can't read the Inuktitut, so I'm not sure about that, but it's not in the French version. But of course we have a very northern francophone national anthem. Mon pays, c'est l'hiver. Mon pays, ce n'est pas un pays, c'est l'hiver. Mon chemin, ce n'est pas le chemin, c'est la neige. Our Arctic sensibility bridges both solitudes. And O Canada is our official national anthem in English Canada, but our unofficial national anthem is Northwest Passage by the great Stan Rogers, who died far too young in 1983. Yes. And for those of you who listen to CBC Radio or are fans of classical music, Glenn Gould's The Idea of North. Cheryl Grace wrote a fabulous book about all this, about the idea of North in our literature, in our culture. And Glenn Gould features prominently there. And in a somewhat less highfalutin form of culture, Joey Shithead and DOA. Joey is now a city councillor in Burnaby. But once upon a time, he was true, strong, and free. And notice, there's the maple leaf, right? So this is in heavy punk rock and that Arctic sensibility coming through. And in a perhaps crass marketing ploy, the city of Vancouver, located in a temperate rainforest, appropriates an Inuk symbol, an Inuit symbol, the Inukshuk, for the Vancouver 2010 Winter Olympics. So it's there, right? It's part of our culture. The Arctic is omnipresent in our Canadian sensibility. That's my point. And it's something that has become part of our political atmosphere and our political strategizing and our conception of who we are vis-a-vis, that big neighbor of ours, the United States. This is the U.S. Coast Guard ship Icebreaker. You see it's had some damage from ice. It's the Polar Sea, which sailed through the Northwest Passage in the summer of 1985. Everything was being managed quite nicely between the Canadian government and the American government. Well, no, I'm getting to that. You're preempting me repeatedly. Just wait, I'm going to get to it. The Canadian government and the U.S. government had this sorted out diplomatically. It was going to be an uneventful voyage until a friend and colleague of mine at the University of Toronto, Franklin Griffith, wrote an op-ed about the upcoming voyage in the Globe and Mail, and the proverbial snow hit the fan. And another friend of mine, now deceased, Mel Hurtick, the president of the Council of Canadians, chartered a small plane and flew over this ship in the Northwest Passage and dropped a six-pack of Molson Canadian on board, along with a note that said, "Welcome to Canada." And turned this into a popular consciousness forming moment, right, of the Arctic versus the United States and sovereignty and politics. And it all became rather intense, and it was only some very clever, subtle diplomacy by Brian Mulroney 3 years later in 1988 that brought the crisis to a close, signing the Arctic Cooperation Agreement with President Ronald Reagan, whereby the Americans promised to request permission in advance of any future voyages by their icebreakers, and Canada very diplomatically promised to always give permission when asked. But it was there as a nation-forming moment. Thank you to Franklin Griffith and Mel Hurtick. And political leaders have never been shy about taking advantage of our Arctic sensibility. This is our former great leader, Stephen Harper, tapping into our Arctic sensibility for electoral purposes. And yes, he is actually technically in the Northwest Passage on this ship, although it's not an icebreaker or an Arctic offshore patrol ship because he wasn't able to procure any of those. But the symbolism still was something that he had very effectively tapped into. And to give you another example, and this is a Harper move again, Harper wanted to get the Arctic into your consciousness even more by putting an Arctic ship on the $50 bill. The problem was that the Canadian Coast Guard icebreaker, the John Diefenbaker, that Harper announced would be built in North Vancouver, was moving so slowly into the procurement process that not even the design had been finished, let alone a construction contract. And they couldn't put a ship on the $50 bill that they weren't sure would ever be built. And so in a brilliant move, a group of Arctic marine scientists at Laval University who run our research icebreaker, the Admundsen, said, well, why don't you put our ship on instead? Now, the irony here is that not only is it not a sovereignty assertion vessel, it's a science vessel, but it's named after a Norwegian explorer. I mean, science is international. That's why this ship was named after a non-Canadian. A deliberate move to signal to the international community that we recognize that Arctic science was international. But it kind of took the force out of the flag-waving sovereignty assertion that Mr. Harper might have intended. And then space. We're a space country, Canada, right? We were the third country in space, right? This is Alouette 1. This was our 1962 satellite. So just 5 years after Sputnik, we put a satellite in space. And instead of just beeping out a radio signal to tease the Americans, which is what the Soviets were doing with Sputnik, we put up a science satellite to study the ionosphere, an upper level of the atmosphere that was interfering with long-range radio transmissions. And we're a big country. We needed to figure out how to do long-range radio. So we had to understand the ionosphere. So we had to build a satellite. 1962.
Where did it go up from?
It went up on an American rocket. But don't think that rockets are all that important. They're not. It's like hiring a moving truck to move your furniture, right? What matters is the furniture, not the truck. In 1972, we built and operationalized the first civilian communication satellite in geostationary orbit. This is Anik 1. Now, why did we do this? So that the CBC, the Canadian Broadcasting Corporation, could broadcast from coast to coast to coast, because we're the second largest country in the world. We have a public broadcaster. Well, people in Whitehorse, people in Fort Simpson, people in Iqaluit deserve, as Canadian taxpayer citizens, to be able to listen and to watch the CBC. Bingo, 1972. We're there in geostationary orbit with a civilian communications satellite.
Was that the first one in the world then?
Yeah. And then, of course, the iconic Canada arm. First of all on the space shuttles, and then on the International Space Station. This was built by McDonald Detweiler, which started, well, here at UBC, half a century ago with John McDonald and Vern Detweiler. We're very good at robotics in this country. The robotics themselves started at Spire Aerospace in Montreal, which was then bought by McDonald Detweiler. But yeah, this is a big symbol of Canada in space, which is why we've plastered the name Canada all over it. It's our contribution to a 15-nation collaboration in the International Space Station, an object, a habitation in low Earth orbit the size of a football field. Right? And an essential laboratory in microgravity where we're doing all kinds of cutting-edge science on things like the growth of cancer cells. I learned a few days ago from Serena Chancellor, a NASA astronaut who was here on campus, that cancer cells grow better, at least some of them, in microgravity. So if you want to actually study cancer cells, well, you get a better look at what's going on if the cells are growing in microgravity than if they're growing here on Earth. So this is our contribution to the International Space Station, and we are oh so very proud of it. We put it on the $5 bill. And I have a theory, and I'm sure that there's a literature on this, and I haven't looked for it yet, about the use of bank currency, right? Of national bank currency, of actual paper notes, and the things we put on them as reflections or contributions to shaping national consciousness, right? I mean, it's no accident. The two things I'm talking about, the Arctic and space, both appear on current bills in Canada. This is RadarSat 2. The other thing that McDonald Detweiler did really well was to pioneer synthetic aperture radar, which enables you to produce high quality images even at night and through clouds. This satellite technology was designed with the Arctic in mind. It's often dark, especially in the winter. It's often cloudy or foggy. And again, 40% of our country is Arctic. We also have the world's largest maritime zones because we have the world's longest coastline. This is our eye in the sky. Before RadarSat 2, we had RadarSat 1. And as you'll see in a few minutes, we're about to launch RadarSat Constellation. And this, too, has been part of our national consciousness. Some of you might remember back in 2007, 2008, there was a big national controversy because McDonald Detweiler wanted to sell its space division to ATK, a big US-based arms mega company. And a whole bunch of people fought against that sale, and RadarSat 2 stayed Canadian. So it's, again, part of our Canada country of space story that I'm trying to tell. And then, of course, was there anything more iconic than Chris Hadfield singing Space Oddity in the International Space Station? If you haven't seen this, see it, listen to it. I was very cynical about Chris Hadfield's very, contrived use of social media to turn himself into a mega star who could then make millions and millions of dollars after his retirement from the Canadian Space Agency. I was cynical about this. He's singing a David Bowie song called Space Oddity, which is absolutely priceless. And I saw the song and I started to cry. He just completely destroyed my cynicism. This is magic, right? And it's magic not just in Canada, right? And the inspiration and the connecting of global pop culture with space, with that mustache and the red shirt. I mean, this is Canada, right? This is as Canada as Joey Shithead and DOA. Yeah, and you know what? There was a guitar already on the space station, but he brought one up anyway because they wanted to do this so very badly they needed a backup. We also have an astronaut as our Governor General. Right? Think about that. Right? We're really good at astronauts. There's actually a little bit of a cynical point there. Right? We do stuff in space so we can get astronaut slots. Right? We build Canadarms so that we get rides to the International Space Station or on the space shuttle. Right? And then we celebrate our astronauts. Aaron Boley and I played a bit of an experiment last week. We brought a non-Canadian astronaut to UBC because we were actually curious as to whether an audience would come in large numbers for an astronaut from another country who they'd never heard of. And fortunately, UBC students and faculty are savvy enough to realize that when you have the person who's in charge of medicine for NASA coming to campus, that you really should go and be part of that discussion. But our space program is largely wrapped up in these symbols, these personalities. And Julie Payette is no exception, right? I don't think she'd be Governor General if she hadn't been to space. Right? And the gentleman who she is presenting the Order of Canada to will come up later in my story. His name is Mac Evans, and he was the longtime president of the Canadian Space Agency. Now, the Arctic and space are connected. I gave, my first lecture was all about this, this lithograph produced by Konojak Ashevak. It's a stunning piece. It was commissioned for the creation of the territory of Nunavut. It's really big. It's 2.3 meters by 3.7 meters. And the really cool thing about it is that it's three-dimensional. She managed on a two-dimensional surface to produce a three-dimensional.
She's female.
Oh yeah. And the thing about this is it's three-dimensional in that it has space as well as the ocean, as well as the ice, as well as the land. And then the kicker for my first lecture was that, in fact, it's four-dimensional. And I thank the audience member in that first lecture who pointed that out to all of us, because it's also about the seasons. The fourth dimension is time. So it's the ocean, it's the ice, it's the land, it's the seasons, and it's space. And everything is revolving around space, and everything is connected. And the Inuit navigate it by the moon and the stars. Like all indigenous people, their culture was inextricably linked to celestial bodies. And in this piece of art, Konojak Ashevak manages to capture what my McLean lectures are about, that the Arctic and space have to be seen as one, and that Canada is the quintessential Arctic and space country, along, and I don't talk about this much in these lectures, along with Russia.
Where is that now?
And the Arctic and space have been connected in all kinds of other ways subsequent to the colonization of the Arctic by Europeans, and here's a very strong connection that emerged during the Cold War. Intercontinental ballistic missiles fly through space. And if they're going between the Soviet Union, as it then was, and the United States, in either direction, they're going over the Arctic. And so during the Cold War, the Arctic was militarized through, among other things, radar stations designed to identify those missiles, those rockets, and to provide enough of an early warning so that a retaliatory attack could be launched. There were also bombers which flew over the Arctic, and this radar here on the left-hand side is actually designed to see aircraft. But the point is that the Arctic was militarized, turned into a giant surveillance front line because of these missiles that would fly through space on ballistic trajectories, thousands of kilometers above the Arctic, but possibly being seen from the Arctic to enable the mutually assured destruction that, at least in theory, prevented the nuclear holocaust. Sorry, that's a little bit intense. But I'm a child of the Cold War, and these things impacted on all of us who were alive then. Another way that the Arctic and space are connected is through communications. This is a Telesat satellite that was launched just last summer. Like Anik 1, it's in geostationary orbit. And the interesting thing about this particular satellite is that a fair bit of its capability is directed at communities in Arctic Canada to provide broadband internet connectivity from geostationary orbit 35,000 kilometers above the equator. And it's a Telesat satellite. Telesat is the 5th largest satellite operating company in the world, and it's based in Ottawa. So communications, absolutely essential for Arctic communities. done through space. You can't run fiber optic cables across the entire Arctic, especially through all of the channels between those islands. Space is the way to provide those services, and that's what we've been doing for decades. And then there are these. Anyone who goes into the backcountry of British Columbia or goes sailing or kayaking along this coastline and doesn't have something like this is an idiot. Okay? This is a handheld search and rescue beacon available at Mountain Equipment Co-op for about $300. And because of an international organization called Cospus Sarsat that was created in 1979 by the Soviet Union, the United States, Canada, and France. When you send out your signal, or if it's on your sailboat and it sets itself off when it gets wet automatically, or it's on your small plane and it sets itself off automatically when it has the high G-force of impact, a signal goes up. And it's captured almost immediately by one of around 50 satellites. Russian, American, French, Canadian, European now. And these satellites not only receive this beacon, they immediately transmit it back down to a ground station. And using the Doppler effect, the change in frequency as the satellite passes overhead, they can pinpoint the location. And they inform within a few minutes the nearest search and rescue station, which in the case of the West Coast is probably the Cormorant search and rescue helicopter based at Comox that will go out and rescue you. Right? Done through space. Now, in the Arctic, these things are even more important. If you go into any small community in the Canadian Arctic and you walk into the RCMP office, because there are 2 RCMP officers in every single community, there will be a string of these up on a nail by the door for the hunters to sign out, to take with them as they go out onto the land. And the reason why the RCMP and the Canadian government want these to be used is because they take the search out of search and rescue. They save lives. These worldwide save roughly 4,000 lives each year. Okay? But they also save governments hundreds of millions, if not billions of dollars in search exercises, because we know exactly where the beacon is. Done through space in the Arctic. And even an illiterate Inuit hunter who might be 80 years old knows how important this device is. And then there's Earth observation, remote sensing. We know so much about the Earth because of our capacity to take images from space. I showed you RadarSat-2, synthetic aperture radar. This is an optical satellite. This is a Sentinel satellite owned and operated by the European Space Agency. But images produced by Sentinel are used by Canadian companies, by Canadian farmers, by Canadian fishermen, by foresters. Remote sensing is ubiquitous now. It's part of our global economy. It's part of day-to-day government activity. The Canadian government's consumption of remote sensing data has increased 50 times in the last 10 years. This is so useful. You can actually measure a decrease in the elevation of the Greenland ice cap down to a few millimeters from space. For climate science, these satellites are absolutely critical. And for the Arctic, which is on the front line of climate change, right? Because the Arctic exists in that precarious balance between ice and water, between frozen and unfrozen, right? This technology enables us to much better understand what is going on. And most of these satellites are in polar orbit because they need to pass over the same places on Earth at the exact same time every day. And because they're in polar orbit, they converge over the Arctic. And so the world's largest commercial ground station is located on Svalbard in the high Norwegian Arctic. There are actually 40 dishes, but I chose this picture because of the aurora, which is another connection between the Arctic and space. And then just as an aside, the Arctic is used as an analog for space. So this is Devon Island in Nunavut, which is used by NASA as a Mars analog. I could have shown you a picture of a bunch of astronauts in spacesuits walking around in a crater in Nunavut, right? Like training to be walking with that bulky, uncomfortable spacesuit. But this is a rover, and rovers are pretty important too. But the point here is that the Arctic is used for space science. And as I explained before, space science is used in the Arctic. So it's all connected, is the point. Much more than most people would think. It's also connected in terms of space junk. We've launched 5,000 large satellites into orbit since 1957. And not just satellites, but also rocket stages and space stations. Stuff comes down. Stuff in low Earth orbit encounters just the slightest amount of friction and gradually comes down and eventually re-enters. In this case, in 1978, a Soviet nuclear-powered surveillance satellite with 50 kilograms of high-grade uranium came down over the Canadian Arctic. And that's actually the debris field, the search field that Canada used to actually find some of that radioactive debris and clean it up. But this stuff happens all the time. Not with radioactive materials anymore, because we figured out how to power satellites and spacecraft with other sources of energy for the most part. One of them, hydrazine, is not particularly environmental. The other, solar power, is very environmental. But yeah, there's a story here about space debris and the Arctic actually being used as a disposal site quite deliberately for some of this debris. So it's not all a warm, fuzzy, happy story. There are challenges involved as well. So back to the Arctic. We as a country, Canada, have actually been pretty good at engaging with problems that arise in the Arctic, including with regards to other countries. So this was back in 1969. This is the SS Manhattan, which is an ice-strengthened oil tanker that sailed through the Northwest Passage to test the viability of that route to move oil from the North Slope of Alaska to the Gulf of Mexico. It wasn't actually carrying much oil. I mean, it had its fuel, oil, and it had a symbolic single barrel of oil. But it went through the Northwest Passage, and it did so without requesting permission, although the Americans thought they'd discovered a loophole in that Canada at that time only had claimed a 3 nautical mile territorial sea. And that meant that there was a high seas channel through the middle of the Northwest Passage. So they decided to sail through without asking permission. But of course there was a lot of ice and they ended up having to divert into Canadian territorial waters. And they actually got stuck on 10 separate occasions. But fortunately, Canada had sent an icebreaker along, the John A. Macdonald, which released the American ship from the ice all 10 times. But that's just a story. The interesting thing about this is that in response to this voyage, Canada introduced the Arctic Waters Pollution Prevention Act, one of the most advanced pieces of environmental legislation in the world, 1970. And then Canada negotiated very hard at the United Nations to get the right to have such pollution prevention jurisdiction recognized in the UN Convention on the Law of the Sea. And so this was a response by Canada to, first of all, a challenge by another country, but also to a new threat, the threat of oil spills in Arctic waters. And the response was diplomatic, and the response was successful. And what made it a success was that Canada identified, in fact, the father of one of the members of the audience here, Alan Beasley, identified that the Russians, the Soviets, had the exact same interest as Canada did. And so we two-teamed Russia and Canada against the United States in the negotiations to get the result we wanted, which is Article 234 of the Convention on the Law of the Sea. I mean, the Americans would have received a concession somewhere else in the treaty, but it was still a successful negotiation for Canada. I've already mentioned the Arctic Cooperation Agreement, where we dealt with the voyage of the Polar Sea in 1985 by some high-level diplomacy with the American president, resulting in this agreement to disagree that actually has worked to this day. Just 2 summers ago, the U.S. Coast Guard wanted to send a vessel through the Northwest Passage. It was the U.S. Coast Guard cutter, the Maple, ironically named. The Maple wanted to go from its home base in Juneau, Alaska to Maryland for a midlife refit. They wanted to use the Northwest Passage. They came to Canada and said, you know, we want to use this agreement to disagree. We're requesting permission. Canada said, thank you for asking. Of course we give permission. No problem whatsoever. And interestingly enough, later that summer, we did the exact same thing, used the exact same template when the Chinese government wanted to send their research icebreaker through. So I don't often say good things about Brian Mulroney, but he nailed it on this one. And his foreign minister, a man named Joe Clark, was probably the brains behind what really happened. And then in 1996, we led the creation of the Arctic Council, proactive diplomacy, seizing upon an opportunity that had been created by Mikhail Gorbachev to use the Arctic as a venue for increased cooperation between Russia and Western countries with a priority on sustainable development and scientific cooperation. And it started small. This is just a declaration. It's not even a treaty. But it's the Ottawa Declaration. And it has led to a very robust institution that has done a great deal of good in the Arctic, including initiating the negotiation of treaties on search and rescue, on oil spill preparedness and response, and most recently on scientific cooperation. And this institution has continued to operate without even a hiccup after the Russian annexation of Crimea in 2014. So Canada is still talking with Russia. The United States is still talking with Russia and cooperating in the north, in large part because of Canadian diplomacy. We've also been engaged in development in the Arctic, and there are lots of journalists who talk about, you know, the challenge posed by big global mining companies and oil companies and shipping companies to the Arctic, but there's some good news stories. This is the Mary River mine site on northern Baffin Island. And it happens to be situated on Inuit-owned land. When the Inuit were negotiating the Nunavut Land Claims Agreement, they hired some absolutely world-class geologists, because the Inuit realized that they were only going to get less than 5% of Nunavut land as completely theirs, including the mineral rights. One of the things they surrendered in the Nunavut Land Claims Agreement were their Aboriginal rights to the territory as a whole. They got things in return, but they also knew they were going to get a small amount of land where they would own the mineral rights, and they hired some absolutely fabulous geologists, and the geologists told them where those Inuit-owned land should be. And one of those locations just happened, and the Inuit knew this, to be one of the world's richest deposits of iron ore. So this is an operating mine. And that ore is shipped from northern Nunavut to Rotterdam, where it goes straight into the steel factories of Western Germany, of the Ruhr. It doesn't even need to be refined, it's so pure. And most of the workers are Inuit, and there's a revenue stream that goes to Nunavut Tungavuk Incorporated, which is the land claims organization. It's a remarkable success story. And yes, there are negative stories as well, but I just wanted to make the point that we have done some things in the Arctic in terms of what might be called, if not sustainable development, at least partnership development with the first people.
Where is it?
Northern Baffin Island. And then there's tourism. Some of the tourism is small scale, little pocket cruise ships where most of the passengers are amateur ornithologists with big binoculars and cameras. But even bigger cruise ships have been coming to the Arctic in recent years. This is the Crystal Serenity, which is a very large cruise ship, a luxury cruise ship that has sailed the Northwest Passage twice. But tourism is coming, and some of it is good, particularly the small expedition type tourism that is led out of Arctic communities by Inuit hunters out onto the land. And you can actually go to Pond Inlet in the springtime, and an Inuit hunter will take you out to the ice edge, and you can sleep in an igloo, and you can see the wildlife from the ice edge. So there's some good tourism that's happening also. Of course, there are risks. This is not in what I would consider the Arctic. It's in the Aleutian Islands of Alaska. But it gives you an example of what can go wrong when a ship's engine conks out, when it's in a storm and close to a rocky coastline. This ship was full of soybeans, but it had over 1 million liters of fuel oil on board, and the U.S. Coast Guard didn't even try to clean it up because of the remoteness and the very very rough weather conditions at the time. So this could happen in the Arctic pretty easily. I've mentioned in a previous lecture that the Arctic is a very dangerous place. Since 2011, I've lost 4 colleagues in accidents in the Arctic. So bad stuff can happen, and does. In terms of shipping, one of the greatest risks actually involve what's called icing. People get really excited about the fact that the sea ice is melting, because this allows for better access and the possibility of accessing resources or using the Northwest Passage as an international shipping route. What they don't realize is that the Arctic remains dangerous. And when you have open water and an air temperature that's below freezing and gale force winds, the spray freezes on the superstructure of the vessel. And that can cause the vessel to overturn. So this is exceedingly dangerous icing. And it's actually happening with greater frequency. And the storms are getting more extreme in the Arctic, just as they're getting more extreme around the world. So there are dangers. And then, of course, there are the social, economic conditions of Canada's northern peoples. This picture made it onto the front page of the Globe and Mail a number of years ago. I mean, it's shocking. It was below 0 degrees Celsius on this day in Iqaluit, and yes, those are children, and they are sleeping because they have nowhere to go. But the socio-economic indicators in northern Indigenous communities are almost beyond description. A suicide rate that's upwards of 20 times the national average, endemic tuberculosis, a housing crisis that's more extreme than anything we see in the South, with upwards of 15, 20 people sharing a single 2-bedroom home. I mean, it just goes on and on and on. And also one of the highest birth rates in the world, which only exacerbates the challenge. And there are all kinds of reasons for this, including the fact that that the Inuit were forced into settlements and lost their traditional way of life, which gave the young men a sense of purpose and value. But ultimately, the fundamental cause for all this is colonization, right? It's the exploitation of these people by people from the south. Now, Canada and the Arctic, what have we been doing? Well, we've been missing some opportunities. This gentleman is Paul Cellucci, who passed away a few years ago from Lou Gehrig's disease, but I got to know him when he was U.S. ambassador to Canada during the first term of George W. Bush's presidency. And he had a strong interest in the Arctic and actually formed the personal view that the United States should recognize Canada's legal position in the Northwest Passage. We have a dispute with the United States. Right? The U.S. has long held that it's an international strait open to ships from all countries. Mr. Cellucci said that's a stupid position, because if it's open to everyone, that means it's open to North Korea. It means it's open to Yemen. It's open to Panama and Liberia, and terrorists could take advantage of this. He said, it's a Wild West argument. And we're talking about the longest coastline of North America. So his personal view, which he expressed to the media while ambassador, was that the United States should reevaluate its position and consider endorsing Canada's. That the Northwest Passage is Canadian internal water subject to the full force of all Canadian law. Now, successive Canadian governments were not interested in taking what was clearly an invitation to negotiate. Right? This is the U.S. ambassador. Right? This is as close to an invitation to negotiate as you could imagine, telling the media that in his view, the U.S. should reconsider. But successive Canadian governments have refused to engage with the United States on the Northwest Passage because of a concern that the Canadian people will be outraged by any possibility of negotiating away part of Canada's sovereignty. So again, by wrapping themselves in the Arctic flag, Canadian politicians have tied their hands in terms of diplomacy on this issue. So Mr. Cellucci and I organized a model negotiation involving non-governmental experts from both countries. We came up with 9 concrete recommendations. We didn't manage to solve the sovereignty dispute, but I like to think that we showed that dialogue could happen. But again, Canada has refused. I'm not suggesting that Canada should negotiate the Northwest Passage now with the current administration. And I really hope that Donald Trump doesn't learn about the Arctic. But we have, for many years, missed an opportunity because the ice is melting and more ships are starting to come, and having a dispute with the United States on this issue is not in either country's interest. I've also pointed out in a very recent article published in the Chinese Journal of International Law, along with a former undergraduate student of mine named Emma Lodge, pointed out that the Chinese have a dispute over the Chungchou Strait between Hainan Island and mainland China, that in terms of its history and in terms of the legal positions is almost identical to the Northwest Passage. The Chinese claim that the strait is Chinese internal waters. One country opposes their position, namely the United States. Chinese steps to consolidate their position have followed Canada's to the T. And Emma and I have gone so far as to suggest that Canada should initiate discussions with China about this, pointing out the commonality in our positions and also how working together cooperatively in the Northwest Passage, using the full force of Canadian law, could actually facilitate commercial shipping by ships going to and from China. Oh yeah. The other thing that we do but don't do well enough is to provide rescue in the north. I talked about the search and rescue beacons, which are great and are increasingly used. But if you get into trouble in the Arctic and you need a long-range search and rescue helicopter, that helicopter will have to fly from Gander, Newfoundland, Greenwood, Nova Scotia, or Comox on Vancouver Island. And Canada's really big, right? I mean, I should have pointed this out when I showed the map of Canada, but Canada is exactly as tall as it is wide, okay? Yeah, it's exactly the same distance from Sandspit to St. John's, Newfoundland as it is from Point Pelee to Alert, right? So it takes one of these helicopters 2 days to get to the Northwest Passage from any of those locations, right? And people die as a result. The other thing is that we don't have a lot of these helicopters. We have 14 of them right now, and they're already 2 decades old. And it takes a long time to procure helicopters in Canada. So we need to do 2 things on this particular front. We need to base one of these helicopters in the Central Arctic in the summertime when there's lots of things going on, but we also need to start a procurement process because the second largest country in the world with the largest maritime zones and the longest coastline in the Arctic needs helicopters that can fly, as these ones can, for over 1,000 kilometers in a hurricane, and then winch up 41 people and carry them to safety. They put 41 passengers in one of these things. Okay? And it can fly in a hurricane, right? They're amazing, right? But we need them, and we're going to need them in the future. And this government and the previous government have given no thought to this. In terms of the socio-economic circumstances of northern Indigenous peoples, I was going to complain today about the fact that Mr. Trudeau, his government, his finance minister, have conspicuously been breaking Canadian law with regards to things like Jordan's Principle, the equal treatment of Indigenous children on reserve as compared to non-Indigenous people, in terms of things like healthcare and social services. You all know the story of Cindy Blackstock and how she's been fighting this government and the previous government on this issue through the Canadian Human Rights Tribunal and through the courts, and winning consistently, and the government has been pushing back. Well, it turns out that Jane Philpott did something really good before she resigned a couple weeks ago. She got this into the budget that came out today, which is a pretty significant commitment that will start to make a difference. But I chose the story from the Aboriginal Peoples Television Network, National News, just to point out that Indigenous peoples are a little bit cynical about this. Note the words pre-election in the title. So we'll see. But we need this, and we need it dramatically. And it's easily doable. The population of Nunavut is about 35,000 people, right? Now, can you imagine a community in southern Canada that had endemic tuberculosis and a suicide rate 20 times the national average and a massive grinding housing crisis? What the federal government would do to fix that and how quickly it could be done in a small community like that? Well, that's Nunavut. Right? This is a question of political will. So let's watch this space. I mean, something did happen today, and again, I think that Philpott deserves credit for this, probably because of all the conversations she was having with Jody Raybould-Wilson. We lost a couple of really important cabinet ministers in the last month or so. Other things we've been doing, shifting to space. Canada has a single military satellite. This is called Sapphire. It's up on a stand right now in this picture, but it's actually, at the moment, up in space. And our single military satellite tracks space junk. That's its only purpose, is to track space junk. Because space junk, space debris, which is the result of those 5,000 orbital launches and collisions, and as a result, literally millions of pieces, some of them quite small, all flying around at 17,000 kilometers an hour. Space debris, especially in low Earth orbit, poses a major threat to every satellite in low Earth orbit. Right? A paint fleck can go right through a spacesuit during a spacewalk and kill an astronaut. Right? Something the size of a golf ball could destroy the International Space Station. And operational satellites have already been lost to space debris. And roughly a third of the satellites in orbit are military satellites. So militaries are very, very worried about space debris. And they collect as much information as they can about the precise trajectory of individual pieces. They get down to about the size of an orange now. And all this information collected around the world by all kinds of different national governments and private companies, including the Canadian military, all goes into a catalog that the US military runs. And the US military then has these big computers that calculate upcoming impacts. And then they alert the satellite operator or the space station operator that there's an incoming piece of space debris. It's going to hit your satellite. It's going to hit the International Space Station in half an hour. The satellite operators can boost their satellite out of the way. The International Space Station has been moved on at least 20 occasions in the last 2 decades. Right? So it's a curious example of militaries actually obsessing and acting on an environmental issue out of their own self-interest. And Canada is leading there, so good for Canada. This is RadarSat Constellation. Well, it's not an actual photograph because RadarSat Constellation is sitting in a warehouse in Silicon Valley right now, waiting to be launched on a SpaceX Falcon 9 in May. This is delayed, but these 3 satellites together will provide almost constant coverage of Canada's maritime zones and the Arctic from space. RadarSat 2 was just 1 satellite going around the planet, so there were big gaps in coverage. The 3 satellites will enable almost constant coverage. So it's the same technology producing the same kind of imagery, but much more consistently with a lot more capacity. And if you're curious as to why the launch is delayed right now, it's because Canada wants to use a pre-flown rocket because SpaceX gives discounts on that, but they don't want to use one that's been too heavily used. So the rocket that launched the Crew Dragon to the space station just in the last 2 weeks is Canada's rocket. That's the one that we're going to use because it doesn't actually doesn't put much stress on these rockets anymore just to launch to the ISS. They launch the ISS, they land, and they fly again. Thank you, Elon Musk. But this is going up, and that's kind of cool. The only problem with this is that the Canadian government's demand for this kind of imagery has increased so much that almost all of this imagery will be used by the government itself and not be readily available to the space industry. It will trickle down to scientists, although not immediately. And there's a really strong argument for completing the constellation because the original plan was for 6 of these satellites, not just 3. This is from today. This is Bennu. Bennu is an asteroid. It's a near-Earth object, which means we can get to it. And we got to it. And we took a picture and sent it back. This is from today. It's an asteroid, 500-meter asteroid, ancient, over 4 billion years old. Right? This is a remnant of the formation of the solar system. And I say we because the laser altimeter on the probe is called OSIRIS-REx. The laser altimeter is made by Canada, and one of the PIs, principal investigators, is right here at UBC, Catherine Johnson. This is a Canadian story as well as space is everyone, I guess, but we're part of this, and that's really cool, right? And we need to know about this because in the middle of the 22nd century, Bennu is going to pass really close to Earth, close enough that it will be affected by Earth gravity, so that on one of its next passes, it could potentially impact. And yeah, that would be a bad day. So we need to figure out more about Bennu, and we're doing it in partnership with NASA. This is the Lunar Gateway, a plan for the Lunar Gateway. When Donald Trump became president of the United States, he redirected NASA from Mars to the moon because he calculated, or someone told him, probably Fox News, that NASA wasn't going to get to Mars while he was president, but they could get to the moon while he was still president. So he told them to go to the moon. And NASA, which, I mean, they're smart, they're rocket scientists, said, okay, well, if we're going to go to the moon, we're going to build a gateway that we could use to go to the moon and, go to Mars. So this is the plan. It's essentially a gas station rest stop in cislunar orbit. So it passes close to the Earth, so you can go get on board or come down from it when it's close to Earth, and then it goes close to the moon, which is when you can get off or back on it. So it's kind of like it's in transit all the time. It's going to have all kinds of high-tech stuff on it, a lot of AI, and it's going to, we now know, have a Canadarm. Because Canada is just committed to building Canadarm3. Cost us around $2 billion. And as a result of that, we'll get astronaut slots. So it's a good thing, I think, and it raises some interesting questions and opportunities. But Canada is part of this. There are 3 confirmed partners: NASA, the Canadian Space Agency, and Roscosmos, the Russian Space Agency. Because space is international. Okay, so what are those opportunities, challenges? This is the actual signature ceremony for the Outer Space Treaty in 1967, the Constitution of the Heavens, okay? Big, important treaty that has done a lot of good, including by preventing Neil Armstrong and Buzz Aldrin from claiming the moon for the United States, right? The superpowers realized that having a sovereignty competition in space would only increase the risks of war. So no national appropriation of the moon or other celestial bodies. Outer Space Treaty, pretty important stuff. Cold War stuff, right? Getting things done despite the threat of nuclear holocaust. Well, this is where I get to talk about the stuff that Aaron Boley and I are trying to do here at UBC and more broadly with our new Outer Space Institute. We just set up a project on the future of space governance, which would involve drawing upon the Outer Space Treaty for a new governance instrument that would be centered on that Lunar Gateway. Because the gateway is kind of a funnel that everything is going to go through. So if you get the governance of the gateway right, like we did pretty much for the International Space Station with the Space Station Agreement, right? If we get the gateway right, then we have some control over what people do when they get through the gateway. Whether it's establishing habitations on the moon or Mars, whether it's engaging in mining, whether it involves the disposal of waste, and who in their right mind would want space debris in cislunar orbit. So we see the Lunar Gateway as an opportunity to do a next generation of international space governance. And Aaron and I are not going to lead this project. That gentleman I showed you receiving the Order of Canada from Julie Payette, Mac Evans, is going to be one of the co-leaders of this project, former president of the Canadian Space Agency, together with David Kendall, who is a space scientist turned policy advisor at the Canadian Space Agency, who just recently finished a term as the chair of the United Nations Committee on the Peaceful Uses of Outer Space. So that's one of the things we're trying to do, is to try to seize on this opportunity and have Canada at the forefront doing diplomacy in this forward-looking, constructive way. This is one of the coolest people I've ever met. And he's part of our Outer Space Institute also. His name is Moriba Jah. Moriba has the most wonderful, exotic life story, which includes having immigrated to the United States by agreeing to work for the US Air Force for a number of years. He actually guarded nuclear missiles in North Dakota. That was his job. That's how he became a US citizen. And when he was there, he actually spoke with a lot of the technicians and the engineers working on these nuclear missiles and realized he was actually pretty good at physics and engineering. He now has a PhD in aerospace engineering. He's landed most of NASA's Mars rovers. This guy, he landed them. He's now a professor at the University of Texas in Austin. And what you see behind is a real-time depiction of space debris. So what Moriba is doing in partnership with the Outer Space Institute here is trying to provide an even better real-time map of space debris to supplement what the US military is doing, and supplementing it by pulling upon crowdsourcing. Because there are thousands and thousands of amateur astronomers around the world with decent telescopes, good enough to see stuff in low Earth orbit and track it. And all of this data channeled in with enough computing power and enough brains could actually supplement that governmental knowledge in ways that could advance the protection of assets in space and all of the uses that we make of it. And I'm going to tell you a funny little side story about this. Every time that one or another country's military launches a top secret military satellite, okay, they'll broadcast the launch sometimes, and then they'll shut it off after a minute because they don't want anyone to know where the satellite is going to go. And there's a competition among amateur astronomers around the world to be the first to identify the exact orbit of that top secret satellite. It takes about 30 minutes, right? I mean, crowd science, civilian, amateur science can be really good if it's collated and analyzed by someone as bright as Moriba Jah. So this is one of our projects with regards to space debris and tapping into his incredible, not only his incredible knowledge, but his incredible mind-blowing energy. And you'll see him at UBC from time to time. The other thing, and this is a connection between the Arctic and space. I showed this picture in one of my previous lectures. It's a Canadian Coast Guard helicopter in Lancaster Sound, which is the eastern entrance to the Northwest Passage. It's flying across to that ice island over there, which is a big chunk of the Petersman ice shelf that's broken off of northern Greenland and is drifting southwards and is going to cause all kinds of problems for shipping and oil drilling off of Newfoundland. And also is a really interesting scientific phenomena related to climate change. So what the scientists on board that helicopter are doing is flying out to the ice island to fix a satellite beacon onto it. So its movement can be tracked precisely from then on. That's what we do with icebergs and ice islands. We put satellite beacons on them. Huh. Couldn't we do that with an asteroid? This is what Aaron Boley wants to do. He wants to start tagging asteroids, near-Earth objects, so we can detect minute changes in their trajectories that might be caused, for instance, by solar radiation. Right? To tag the ones that are passing closest to Earth. I mean, we try to identify them and track them with telescopes, but tagging them. And wouldn't it be really cool that if instead of tagging along with NASA missions, pardon the pun, we actually started to take on our own missions and had a tagging spacecraft that could be launched as a secondary payload on other rockets that would actually go up and start doing this, to start providing a better roadmap of what's going on in the solar system that could be of relevance to us. And as it happens, in tomorrow's Globe and Mail newspaper, just online now, Aaron and I have an article. And the thing is that tomorrow night at 6:34 p.m. Pacific, a 24-meter asteroid is going to go swishing past Earth. And it's not a problem. It's not going to hit. Okay? But if it were to hit, it could be a bad day. If something much bigger were to hit, like Bennu, that would cause catastrophic damage to an entire continent if it struck one. If a big one, a really big one, a kilometer or more were to strike, it would be a bad day for life on Earth. Right? And these things happen. There are craters around the Earth. Right? And there are a lot more craters on celestial bodies that don't have atmospheres, because the small stuff, right, it fragments as it enters the atmosphere, creates an air burst. But if you look at the moon, which you can on any clear night, right, the thing is just like pockmarked. You know, so is Mars. Right? So we live in a dangerous place. Not dangerous enough that you need to lose sleep about it, but dangerous enough that we need to engage, to be serious, to throw a lot of money and effort at the science of this. And one of the things that Aaron and I have thought through, identified, and he gets most of the credit here, is that there's a lot of interest in asteroid mining now. Because we know there are lots of precious minerals on asteroids, and some of these asteroids come close to Earth. There's also ice on asteroids, which could be rocket fuel that you don't need to lift out of Earth's gravity. So there's a lot of interest in asteroid mining. Well, the astrophysicist says, if you're removing mass from an asteroid, you're going to change its trajectory. So you could actually have a human-caused Earth impact, right? We could go up, some company could go up and start mining an asteroid and unintentionally change the trajectory so an asteroid that was not going to hit Earth becomes an Earth impact risk, which is where the International Lawyer comes involved and goes, well, gosh, this is the sort of thing we need to regulate, especially because some of these mining companies at some point are going to say, well, we had enough of US regulators or European regulators. We're just going to go register a company in Liberia, where they're not going to regulate or oversee what we do. So our point is that we need to actually have an international effort to ensure that planetary science is part of all the decision making with regards to asteroid mining, and the time to do that is now. So that's sort of Aaron and my pet project at the moment, and we're really excited about this because, see this? We're in the Globe and Mail with our brand new institute. The last thing I want to say, and this is the last slide that I added just before my talk. This is Earthrise off the moon. It's part of the reason why I think it's useful to think about the Arctic and space is because the scale of these regions is so very large. And the Arctic is measured in thousands of kilometers. Space is infinite. And it changes your perspective, your sense of scale. It takes a lot of effort to wrap your mind around infinity, or even just big regions, or big phenomena. So most people can't contemplate the fact that we're a little pale blue dot in an infinite universe. They just can't do it, right? It breaks their head if they try to do it. And for the same reason, most people can't actually get their heads wrapped around climate change. They can't do it. Right? It's just too big. we're just small people running around checking our phones, buying our groceries, going to work, right? Climate change is big. Oceans are big. The Arctic is big. Space is bigger, right? And whether it's an insecurity or an inability, I'm not sure. But by forcing people to actually think about these things, not as terrifying, but as exciting, right? As opportunities for expanding our minds, for expanding our conception of self on the opportunities. Little things like space as a way of saving lives on Earth, right? With a little beacon, right? All the practical stuff enables us to find a way into expanding people's conceptions so that they look at this pale blue dot and say, we can solve climate change, right? We can send a probe out of this solar system, right? We've done it, right? We can drive around on Mars in a rover because we're doing that, right? We can go to an asteroid and take pictures and collect a sample. We can do awesome, difficult stuff, right? So climate change, relatively speaking, it's not impossible. It's hard, but it's relatively speaking well within human capability. So my argument, and the last slide argument, is that Canada as an Arctic and as a space nation is also a nation that can lead on those really big challenges that have defied action because our scale, our sense of scale and being has simply been too small. So we're on a pale blue dot, but the universe is our oyster. And we can seize on this in a proactive, optimistic, get things done kind of way. So that's the conclusion I came to as a result of these 3 lectures. Although I suspect there's someone in the audience who's going to cause another shift in my mind in the discussion phase that we can have for, I don't know, 15 or 20 minutes before we retreat to drinks. So thank you very much. Okay, any burning questions? I went on a little bit longer today. Yes, please.
Yeah, so I read today that there was a meteorite that landed in the Bering Sea, December 18th. We just are learning about it today.
Yeah.
How is that not discovered?
Oh, it was a small one, and it didn't land in the Bering Sea. It broke up in the atmosphere. Relative to the one that's